Hi everyone, welcome to another edition of the AnandTech podcast. This is podcast of CES 2018. I'm your host Ian Cutress, and joining me today is the always delightful Ryan Smith, Senior Editor-in-Chief, sorry.
Yes, Editor-in-Chief, aka your boss.
And also joining us today is our Senior Mobile Editor, Andrei Frumuşanu.
How's it going?
And, CES, every year, Las Vegas, 180,000 of the tech industry. We come, we talk tech, we look at all the new things that are coming out through 2018, and we ask what went right and what went wrong with 2017. This week has been particularly interesting because it's actually rained in the desert here in Vegas this week. But we want to start today in the podcast talking about, the major headlines that came out, especially during the first week about CES. We're going to save talking about Meltdown and Spectre for another podcast, just because that is something that is still very much in flux, and we all want to get our teeth into the meat of what's happening. But I do want to start with Intel, because Intel had the keynote of the show. They hired out the massive theatre in Monte Carlo, if I remember correctly, Ryan. This was CEO Brian Krzanich on stage for the best part of 2 hours, describing how Intel is in many technologies. The event itself was very visual. They made it like a Vegas stage production.
Correct.
They had dancers where the scene around them was interacting to how they dance. They had AI creating jazz. They
had drones playing a piano.
Yeah. The keynote was very much on the visual aspect of what Intel is doing. Brian Krzanich did spend a couple of minutes talking about security issues, but it was very quickly onto how Intel is doing lots of basically compute. It's not necessarily, Intel is a manufacturing company. You expect them to talk about manufacturing, but this is a consumer show. So they're talking about ways in which their hardware was be brought to the consumers, and the biggest way they did this was through sports. Having multiple cameras in a sports hall, not only being able to put you within VR into the sports arena in any seat you wanted, but also the ability to calculate the position of everything in the arena with many cameras by using voxels rather than pixels. Now, everybody's familiar with pixels on a screen being a 2D representation, but voxels are a 3D representation of color and physical. I don't want to be explaining this because, Ryan, you're the GPU guy. Voxels have been around for decades.
Voxels have been around for decades. I was going to say compare voxels to Legos, but with this audience, I think compare voxels to Minecraft and you've got about the right idea.
The whole idea with Intel here was that throughout a sports game, they could essentially put you in any camera position, pointed in any direction, and you could see the entirety of what was going on. So if that meant, the helmet of a running back, or the knee as a tight end got smashed in by the defensive end, you could do that. And they also applied this to filmmaking, where they said they shot a Western scene, and you could be the cowboy, you could be the bandit, you could be the bullet, or you could be the horse.
Well, it's not so much you could be, but you could see the view from all those.
Yes, correct.
They're essentially recreating the scene in 3D using voxel representations rather than, polygonal representations. And that's just a matter of having enough pseudo-accuracy to represent everything as voxels.
So, they were using, with the film scene, they were using 100 cameras. They were using that to calculate the points, and they were essentially filling in the blanks with AI. This is, Intel's big thing is we're massive on compute. This is a compute-heavy task which improves a user experience in a new way, and that's been Intel's thing for several years now. How can we use what we have to build a better experience now? The question is if they're going to get any customers, if this is going to drive revenue. This sort of technology is usually 3 to 5 years out from ever being commercialized, but this is something that they always like to promote in these keynotes.
Is there real 3D? Oh, excuse me, not real 3D. What are they calling this technology now? Real
TrueView.
TrueView. There we go. Yeah. So TrueView's been around in one form or another for a few years now. They consider it cutting edge, but they continue to iterate on it, and they continue to have sports partnerships with it. So Intel is continuing to trudge right along.
Two other parts about the Intel keynote were about their sort of emerging computing technologies that are kind of a bit hard to quantify. So the first one is called Loihi. That's Loihi. This is their neuromorphic processor, which is essentially designed to have a processor that acts like a bunch of neurons, like in a brain. There are kind of versions like this that already exist. For example, there's one based on an ARM9 core called Spinnaker, and that is a computer that takes up a room but has, several 100,000 neurons, and it's this weird architecture. But Intel is basically saying we can do something like that, but better, stick it on a single chip, and away you go. Now, I actually had... it was weird. I was on the show floor at Intel's booth for one of their breakfast presentations, and I just happened to come across Brian Krzanich. He was just wandering the show floor, and as a member of the press, it's kind of rare to get hold of a CEO, so I managed to grab him for a couple of minutes. I asked him, one of the questions I asked him was about this neuromorphic technology. Now you guys have a working chip in the lab, because this is such an esoteric paradigm to program for. There's going to be at some stage in which they're going to have to start training people. They're going to have to start doing development programs if they want this to be sort of like a big research chip for high performance compute for the things that it's designed for. He said, yeah, that sounds about right, but we're several years out, perhaps a decade.
Yeah, it's very much a research project right now.
The other thing they had was their new next generation quantum processor. So they're moving from 17 qubits to 49 qubits. This is, in itself, quantum processors, in order to work, they need to be cooled to near 0 Kelvin. And one of the things we also learned was that in order just to calculate the way the I/O is handled within the processor, just to handle the integrity of the data, you need a supercomputer behind it, which requires many megawatts of power plus your quantum chip. Now, there are a few players dealing in quantum chips. The big one, commercial one at the minute, is D-Wave, but we've also got IBM. So again, this is just another technology that Intel is putting into research. One thing they didn't mention at the keynote, which is kind of big in our space, is Intel's new it's not a collaboration, it's a business partnership with AMD for the new Kaby Lake G processors. So this is Intel putting one of their H series processors plus an AMD Radeon Vega graphics die and HBM2 on the same chip. So what Intel are doing are essentially they're buying specialized Vega chips from AMD's semi-custom unit, sticking it onto the same package. So you have a multi-chip package, and then bundling that as a single CPU plus GPU plus high-performance memory solution, which is going to be in processors that come up to 65 watts and 100 watts. And there's been two laptop announcements from HP and Dell, and Intel are going to stick it in the next Hades Canyon NUC. So, I mean, this in itself is the way I described it in the way we wrote the piece is, Intel and AMD are now the best of frenemies. They're friends when it suits them. They're enemies when they have to compete. They compete in x86, but this is one situation where Intel felt the market they were targeting would be better served by buying a graphics processor from AMD rather than scaling up one of their own designs.
Yeah, and saying Intel thought they might be better served is probably putting a little too nice of a spin on it. I mean, they have to have had some pressure from the OEMs, especially the fruit company in California, to get something like this to happen. But it's here. It's being adopted by HP, Dell. It'll be a matter of time until we see Apple do it. So there's definitely a market for it, and it should be interesting to see what comes of it.
Well, Apple's always been pushing AMD graphics in their professional designs, and iOS is built heavily upon OpenCL. So it makes sense that if Intel can't provide the graphics solution themselves with their own graphics technology, that they use AMD to help fill that gap to help Apple along. Now, I've heard this chip is actually fairly expensive for OEMs. and the one company that's likely to be able to amortize that cost is Apple.
Yeah, and that makes a lot of sense. You've got the full cost of a 4-core Kaby Lake CPU, plus the cost of what's essentially 1/2 to 1/3 of a Radeon Vega 10 GPU, plus a stack of HBM2, plus the EMIB, plus everything else that goes into packaging that. So it's very much a unique chip. It's going to be a lower volume chip, and that's going to make it extra expensive.
They gave us prices on the Intel NUCs, the Hades Canyon designs. So the NUCs with the 65-watt processor are coming first, and as a bare bones package, so minus DRAM and storage, that'll be $799 US, and then the full 100-watt unlocked overclockable processor will be $999. So once you add memory and storage into it, say in a good NVMe storage drive, you're easily looking at $1,400, which for a mini PC is actually really expensive.
It is. Well, in this specific case, that's not entirely Intel's fault, because right now we're going through a really terrible NAND shortage and RAM shortage. So there's a reason why it adds $400 to the cost of your system, but at the same time, yeah, you're right, the total price tag is a bit of a sticker shock.
I mean, you essentially, you're paying for a little bit of technology, the size, and the ability to have the latest thing on the market. But if you had that much money, you could easily build a gaming machine with a lot more.
It's very much a play in miniaturization, and that always costs extra.
Now, speaking of AMD, I want to move over to AMD's Tech Day that they held this week. They flew a number of the press out to Vegas a couple of days before the show to essentially go through what I think is one of the highlights of my show. So AMD had a massive year last year with the launch of Ryzen and the launch of Vega. You could argue that if those launches failed, we wouldn't necessarily have an AMD right now. But fortunes are on the up, revenues are up, they're even in the black.
They are.
So compared to last year's Tech Day, where it was all preparation for Ryzen, this is now post, sort of Ryzen honeymoon. And they kind of nipped it in the bud straight away by basically saying, here is our 2018 roadmap. Now, it's been a while since I've seen a company launch essentially what is their next 12 months, or announce what is their next 12 months of products.
Yes and no. AMD's always been fairly straightforward. Perhaps not in this fashion, but we've had their GPU roadmaps going on for a couple of years now. Well, for a couple of years now. But on the CPU side, they've always had a roadmap, but it's always been somewhat generic. This is a little more precise than what we're used to getting, which is a pleasant change.
Well, I mean, they've had their sort of 3-year out to 2020 roadmaps where it's been vague, but this time they said, well, okay, in the first quarter of this year, we're going to launch the rest of Ryzen Mobile. We're going to launch desktop APUs. In the second quarter, we're going to launch Zen Plus. So on 12 nanometer rather than GlobalFoundries 14 nanometer. So that's going to be iterative process updates to be more power efficient. And a new platform. And then in the second half of the year, they're going to introduce Threadripper based on the Zen Plus, and also APUs, if I remember correctly, on Zen Plus as well.
Correct.
So as a CPU roadmap, that's kind of crazy. I mean, I think it's great that they're telling us, when exactly we're getting the rest of Ryzen Mobile. I mean, then it's up to the OEMs to actually make those laptops. We're going to get Ryzen APUs, a Ryzen 5 and a Ryzen 3, cost of $169 and a cost of $99. Hey, you can get a Ryzen-based APU for $100, and it comes with a cooler.
That is a pretty good deal.
That's the specs and the price point put it in a nice situation. I was actually meeting with AMD today, and I was asking continuously, when are my samples coming? When are my samples coming? Soon. I think launch for that is February 12th. Going to be a busy few weeks ahead. I'm going to have to prepare for that.
All right.
Also on the roadmap was on the graphics side. Now, graphics for 2018 for AMD is going to be a little more sedate. They essentially, all they did was essentially announce two things. One, Vega is coming to mobile. So they're producing Vega mobile graphics for laptops. And that they will produce and they will be sampling to customers Vega on 7 nanometers by the end of the year. Now, this is important.
Yes, it is. It's very important because what has essentially been not just not said, but excluded from here is any kind of 12 nanometer GPU, which is a noticeable difference because 4 months ago, when GlobalFoundries announced their 12 nanometer process, AMD confirmed that they're producing 12 nanometer GPUs, and again in earnings calls in October, they confirmed those plans. So unless AMD is playing fast and loose with what they're calling GPUs in the first place, i.e. APUs, it means 12 nanometer GPUs at some point here got cancelled.
But they said shipping at the end of the they said shipping to customers or sampling technically at the end of the year. So it won't be 2018, it'll be 2019.
Yeah, so for what we have instead, the 7 nanometer design, so the 7 nanometer design is coming up. It's some kind of Vega for, optimized for the Ready on Instinct market. Every bit stands to reason that it's going to be some sort of small pipe cleaner part, maybe something to take on class of, say, the current Tesla P4, a small card for high-density blade servers, because 7 nanometer is going to be so raw in that time frame.
Is this essentially going to be kind of like a mini replacement for the Instinct MI8?
Yes, that's a good way of putting it.
Yeah, with a new process, you want to start off with a small chip. You want to go to a market where you can get high margins. So you focus on machine learning because that's just the big thing in compute these days. And yeah, get the process ready for when all the big stuff comes. And they're also relying on GlobalFoundries to execute.
Yes.
So it's not entirely in AMD's hands, but AMD is one of GlobalFoundries' major partners along with IBM.
They are, and AMD pretty much has to take that risk as a result. But yes, GlobalFoundries, of course, struggled to develop their own 14 nanometer node and essentially failed, licensed Samsung's tech. So 7 nanometer is their next big adventure in terms of developing their own node. So we'll see how that goes. As for what it means for AMD's graphic division, in the meantime, it's interesting time, and they've essentially ruled out anything right now that's going to be a major update to consumer graphics other than Vega Mobile. Which, not to discount Vega Mobile, that should actually be very interesting. So we're talking an integrated package like the current Vega 10, GPU dies on top of a silicon interposer, HBM2 memory stack, all in one chip, one small chip, 1.7 millimeters tall. So a little bit bigger than the current Polaris 11 chip, but not by much. So still very, very small chip, much smaller than most high-performance laptop GPUs. So it should be an interesting product for laptops. We'll know more later in the year once it launches, specifications, clocks, etc. Expect something between a third and a half of a Vega 64, basically.
Yeah, they showed us the chip. They wouldn't give us any specs, but it pretty much looks like half a Vega 64 based on physical size, doesn't it?
I wouldn't be surprised if it was 32 CUs, but
it could be as low as 24.
Yeah, because there's a bunch of fixed logic on there that sort of throws off those calculations, but somewhere thereabouts. So it really should be an interesting chip. I say that with a little bit of hesitation, simply because that's the only thing on their consumer roadmap right now for this year. No 12 nanometer Vegas, no replacement for Polaris, etc. So that is the only AMD launch we know about. Admittedly, traditionally, we don't know about any AMD launches in an official capacity, but even in an unofficial capacity, it doesn't look like there's anything else happening this year.
So much gelled on the roadmap in 2017, it's kind of all gone off the road. That's probably a bad analogy. It's just gone off to the outer rim for 2018, and it's all going to come back at some point. These things are cycles.
Yeah, essentially, AMD has one more Vega chip to pull out, which will be Vega Mobile, and then we're waiting for 7 nanometer and Navi in 2019.
So Intel had their keynote, AMD had their tech day. The other big presentation of the week, especially from our side, was NVIDIA. And, a couple of big things came out of NVIDIA. We kind of got a briefing beforehand, and we learned that Uber is going to be using their self-driving technology. Now that is a big contract.
It is and it isn't. So Uber will be using NVIDIA's technology. There's nothing in there to indicate that it's going to be exclusive use. Uber's almost certainly playing the field and trying out everyone. But, it's the gateway to potentially landing the king of all Uber contracts when Uber finally gets to where it needs to be and technology gets where it needs to be in order to have their much vaunted self-driving taxi fleet.
Now, with self-driving and automotive, we've seen NVIDIA over the past couple of years, talk about their SoCs and talk about how they're implementing them. And back last year, they announced Drive PX Pegasus, which was 2 Xavier SoCs and 2 next-gen GPUs. Now, as part of the presentation, they showed off a die shot of the Xavier SoC, which is built on TSMC 12 nanometer. It's coming in at 9 billion transistors underneath 350 square millimeters. And, I just want to run through some of the things here because it's kind of odd to hear about all these things in the same SoC. So we've got 8 ARM cores called Carmel cores. These are 10 wide superscalar cores. It's rated at 2700 spec in 2000. They're doing something called dual execution mode, parity ECC. They've got it's even got a Volta GPU inside, with multi-precision, 512 CUDA cores, 20 tensor cores. That's NVIDIA's special 4x4x4 calculation matrix for deep learning. They've got video processors that go almost up to 2 gigapixels per second decode. They support gigabit Ethernet and 10 gigabit Ethernet. They've got other mini processors and ISPs that do even more tops. We're going to have to dig our teeth into this because this is an SoC that contains a lot of technology, which we rarely, if ever, see together, plus also adds a new few independent things. I mean, when was the last time you heard about a 10-wide ARM core?
Never. Nobody. I think NVIDIA Denver was 7 wide.
Denver was 7 wide. Apple's latest ones were...
Well, can't really talk about it, but they're also quite wide by now.
Yeah.
So.
I mean, the benefits of going wide is that you can potentially do more if the instruction stream is there.
But we still don't know actually if this is like a pure ARM-based architecture or if it's, again, something similar like Denver where they do translation.
Yeah.
So doing something to keep in mind here, the target market for this. This is the first chip to come out of NVIDIA that is only for NVIDIA. NVIDIA, as far as has been discussed, will not be licensing Xavier to anybody as just the chip, but as part of a larger platform. You will become an NVIDIA customer. This isn't going to be for somebody to, say, integrate into a smartphone, for example. This is not in NVIDIA SoC licensing. This is an automotive SoC. This is built to be the cornerstone of all their automotive efforts. So everything we see here, core design, GPU design, inputs, the fact that it's 350 square millimeters is all based on the fact that they're building the brains of an automobile.
I mean, NVIDIA's goal here is we build a package and then we sell a package with the software, with the SDKs to the various automotive companies, as opposed to, say, pairing with one specific company and going in deep integration. I mean, they're talking with all of them. They know what they want, so they're trying to do almost a one-size-fits-all package here. I mean, this is going to be essentially the brains for Pegasus, which is a level 4 autonomous.
Level 5. Pegasus
this is a level 5 one.
Yes, Xavier is level 4. Pegasus is meant to be a complete level 5 service for robotaxis.
It's something we're gonna. It's one of those things. It's the technology underneath is what excites us, even though technically we're never gonna be able to get our teeth into it physically. We can only talk about it in a very contextual way.
Yes,
but. That's Xavier. NVIDIA also talked about their BFG display technology. I mean, Ryan, you saw this. I mean, I saw one in the Asus booth, 65-inch, 4K, 120Hz G-Sync. Is that right?
Correct. I mean, it's basically everything you could possibly want in a monitor in a TV-sized display. Now, to be technically correct here, it is not a TV. Because NVIDIA doesn't put a tuner in it, they're not actually allowed to call it a TV, but it is instead a very large display. And if you're familiar with some of NVIDIA's past projects, such as last year's 4K HDR G-Sync concept monitors, then this is essentially a larger version of those. So you have 4K display, fast refresh rate, G-Sync, HDR support, some kind of full array local dimming lighting. They aren't confirming the number of zones yet, but expect expect a large number of zones, equivalent to where you find on other premium TVs that are doing local dimming as well. So
Are they aiming for HDR?
Yes, HDR. You've got full HDR support. So,
what sort of brightness did they say?
Again, those aren't specs they're confirming right now, but with full local rate dimming, they can hit easily 400, 500 nits at brightness and go very dim in the blacks to hit the contrast ratios required for HDR.
And I assume it's okay. Just headline: 65-inch, 4K, 120 Hz, HDR, G-Sync. Price?
To be determined, but it will not be cheap.
Will you buy one?
Probably not. Let's wait for the 27-inch 4K gaming monitors. On which note, actually, got confirmation from NVIDIA that those 27-inch G-Sync HDR monitors will be shipping this quarter.
Oh.
So the panels are finally ready. So I'm assuming this is going to be later in the quarter here, so probably March. But yes, this quarter shipping, and then their 32-inch cousins will start shipping here a little bit later in this half.
Talking about exciting things during CES, I've got you two guys here. We went around the show floor, when it was not suffering the effects of the drastic rain in the middle of the desert. Things that we saw on the show floor. Now, I'm going to start by saying something that I didn't actually see directly because I actually ran past the booth. But I read about LG's Rollable TV, so they're using flexible OLED technology, which they showed off last year as sort of prototypes, but now they're actually bundling it into another 65-inch TV, where it's literally you roll it up out of it's motorized, rolled up out of like a black box, or was it? It was a cream box. They rolled it up. And then you have, essentially almost as good as you can get with a standard flat panel display OLED. And then you roll it back down again so it takes up less space. Flexible TVs, it's the future. Is it the future?
I don't see the point, to be honest.
Do you not want like a flexible band around your...
Yeah, like in the smaller form factors, sure, but why do you need a flexible TV of that size?
Conceptually, it's cool. Is it the future? I'm going to say this. To date, we have not seen anybody produce and sell a native OLED monitor or TV anywhere near that size. There have always been reliability issues that have kept OLED technology, pure OLED technology, from being scaled up to those size, and which is why you only see WOLED TVs in the big size format today. So this is pure OLED, so it will be interesting to see if LG has worked out the kinks or if they just enjoy showing off flexible displays, because that has always been one of the cool things you can do with OLEDs.
So I saw that at the show, or I saw people talk about it at the show anyway. Ryan, I know you had some hands-on with the new Vive Pro.
I did. So the Vive Pro. So HTC announced essentially a mid-generation upgrade for the Vive family. The Vive Pro, it's aptly named. It's not a complete next-gen product, but instead it takes the current Vive, upgrades the internal displays to a much higher resolution. Going off the top of my head here, 2880 by 1440 display. So you have around a 78% increase in pixels versus the old Vive version 1. It also includes an updated version of their head strap mechanism that was added to the Vive family later on last year as the deluxe audio strap. And it's all around a rather nice improvement over the original Vive.
So my question is, can you still see the pixels?
You can still see the pixels. The screen door effect has not been eliminated. It has been reduced. Depending on what you're looking at in your vision quality, you may not even notice it. But yes, you still look at text or something, look at the distance. If you have good vision, you'll notice it, but it won't be nearly as obvious.
You also tried it with the wireless, Intel's wireless connector.
I did. So the demonstration I was using was set up with wireless on that one. It worked fine. Because I didn't have a wired Vive Pro next to it. I couldn't really compare it side by side in that fashion. But I did have a wired Vive 1 next to it. looked absolutely fine, didn't make a difference, but I was also very close to the transmitter, so it's not like this was a massive field test.
Well, I mean, it uses WiGig 60 gigahertz, so
Correct.
your range is only 10 meters anyway.
Yeah, but in this case,
that's all you
I
need.
was standing like 2 feet from the
Yeah.
PC, so
Yeah.
So it looks interesting. Between the display improvement and especially the strap improvement, I really like it. I won't go on too long about the strap, but one of the biggest problems with the original Vive, the original Rift, they just are hard to get on your head. And the Vive introduced their deluxe audio strap and made it a little bit better, but this one, I had no problem getting this thing on my head. And I have a very big head. Yes, in both senses of the word, Ian.
Yeah. Yeah.
So there's enough range on it to get over my head. It's designed in such a way that it's very balanced front and back, so everything fits comfortably. I mean, it's essentially like wearing an adjustable crown around your head, so the weight is distributed around the entire head, making it very comfortable to get on and very easy to secure in place.
This is where I ask how many crowns you wear in your daily life.
Heavy is the crown of being the editor-in-chief of AnandTech.
Safe answer. But so the deluxe strap is that sort of bendy one where you put it on your eyes first and bend down.
No, the deluxe audio strap is essentially so there's a knob in the back that you twist. So it either extends or retracts the straps, and so you put that on, put it over, just bring it down over your head, line up with your eyes, and then twist the knob in order to tighten it back up. And it really is a massive improvement, because one of the problems I had with the original Vive was getting the actual display to line up with my eyes in the sweet spot, so that I wasn't getting chromatic aberration and blurriness.
Yeah, you end up spending more time trying to get it on the back of your head than you do getting it on your eyes. And when you got the back of your head, you have to sort out your eyes, and you do that, and it moves the back of your head.
Exactly.
Yeah, I know what you mean. Another part of the show where I attended a pre-brief and Huawei had a keynote was that they are launching the Mate 10 Pro into the US market. This was kind of half expected anyway, except that we were also expecting them to have a major carrier announcement with it, because in the US, if you don't have a major carrier announcement, it's very hard to break into the market, and Huawei's tried to break into the market a couple of times now.
So yeah, this was supposed to be a big announcement for Huawei, because that would have been AT&T was planned to be the first carrier of the Mate 10.
Yep.
But, and already Huawei had advertising all over Las Vegas with huge billboards and everything.
Ready to go with the AT&T logo. And
unfortunately, it got cancelled on the last minute from AT&T, so they back. And that was supposedly because the FCC got pressured by
who knows,
somebody in the US government, and they basically said to AT&T, please don't carry this phone. And of course, Huawei, so the CEO during the keynote, he went off script at the end, and he actually did a very heartfelt rant on the state of the US carrier and mobile markets, because basically it's right now quite unique in the world, because 90% of all the phones sold in the US are sold through carrier channels, whereas in Europe, China, or Japan, I guess, most of the phones actually sold unlocked in shops, and you outright buy it.
Yeah.
But still in the US, the carriers have immense power in deciding what consumers are even able to buy. And this decision basically by AT&T, as Huawei's CEO explained it, and I agree, is basically damaging and limiting consumers in the US.
I mean, Huawei's goal is to be, the number one smartphone provider, and they sold 160 million devices last year.
So they're the number 3 smartphone maker in the world.
Yep.
And basically you can't buy them in the US.
Yeah.
So
it's
something quite crazy.
No,
it doesn't make sense at all, the explanation, because ZTE is actually quite prevalent in the US.
ZTE, yeah.
ZTE in the lower end phones, and basically they are owned by the Chinese government.
And they're free to partner with carriers.
Yeah. And Huawei, as a private company, is not allowed.
I mean, you can debate, how Huawei is managed and what ties they have or whatever. I won't go into speculation into that because neither of us know. But yeah, it's for Huawei end up sampling a lot of phones to a lot of press, so you may see significant content towards Huawei against, say, Samsung, which has their sampling program, and Apple have their sampling program. So, I mean, they are trying to get their name out there beyond their traditional markets, beyond China, beyond Europe.
Yes, so basically the plan right now is going forward is still going to try with another carrier to see if they still can manage to introduce a Mate series Huawei phone in the US like that.
It might be a case that they have to go in at the low end.
No. What they're going to do is they're still going to try to... So Huawei has been on the rise over the last few years.
Yep.
At a dramatic rate, which we saw no other smartphone. What they're going to do is they're going to try to improve the phone lineup every single year until at some point the carriers basically have to carry it. Otherwise, they're just going to lose more users to unlock devices sold through other channels.
I mean, I know they've just hired recently in the last few months the former head of Samsung, VP marketing, to head up the US, and she has bought brands like Motorola and Nokia to the US. So she knows the market very well. She knows how to introduce products to the market very well, and she's kind of got one hand tied behind her back already. So it's going to be interesting to see how that plays out. And speaking of smartphones, we got briefed before Christmas on a new fingerprint technology, and I know, Andrei, you had a chance to go play with it.
Yeah, so what we're talking about here is Synaptic's new in-screen fingerprint sensor. So what they do is it's basically like a CMOS sensor, like the ones you find in cameras. And it's integrated beneath the display, and it actually sees your fingerprint through the display, and the display illuminates your finger, and the CMOS sensor behind the screen can read out the fingerprint.
It's almost like a camera that looks through the display.
Yeah.
But the display has to light up around your finger in order to get the reflection back onto the sensor.
Yeah. So, in theory, works well. In practice, works well. So, quite surprising. It works as expected. So, I
mean,
very honestly, I can't say anything against it. And of course, the first phone which implements this is a new model from Vive, so big Chinese company. They didn't actually fully announce the specifications on the model and when it's going to be available, but they were the first to actually demonstrate this technology.
No, normally when that happens, the demo units in Synaptic's booths have the logo of the company they're using with the hardware.
Yeah.
With a sticker over it so you can't tell. And
so it's like a typical high-end Vive model. It's like the unit which I was playing with had a Snapdragon 660. It was quite large form factor, so like 6 inches AMOLED screen, of course. And of course, like going back to the fingerprint sensor, the implementation is only possible with cooperation of the panel manufacturer, so in this case Samsung.
Right.
Because the integration of the fingerprint sensor, basically what needs to happen is like it needs to be put into the screen by the panel manufacturer.
Right.
So that is quite a complex supply chain.
Yeah. But it also means that, well, when you have the fingerprint sensor inside the screen, you don't need to have a physical home button on the front, or like an Apple device, or a fingerprint sensor on the rear next to the camera like a Samsung device.
Correct.
It makes sense with the trend towards having these full screen displays that eventually most, if not all, high-end smartphones are going to probably go this way, unless they keep the fingerprint on the rear, I guess.
So I think like the only really negative thing is like the area itself of the fingerprint sensor is maybe a bit too small at the moment.
Right.
I think the sensor itself was like around 5 by 8 millimeters. I'm not sure exactly. But it did seem a bit small, so you really have to like... Well, oh, of course, when you register your fingerprints, you have like the 30 different positions.
Yeah.
So that's fine. But you still kind of have to hit the center.
And when you've got a 6-inch phone, trying to make sure you hit the right 5.8 millimeter.
I mean, in terms of accuracy of the sensor itself, I didn't have any false registrations. The problem is like you just have to really hit the middle, and compared to traditional fingerprint sensors, which we've seen like on the back of Huawei phones, Pixel phones, those are quite bigger.
Yes.
So that's less of an issue.
I mean, this is the first generation.
Yeah, it's the first generation, so it is quite a breakthrough technology, which we've been awaiting for like more than a year.
So what you're saying is I can finally have an iPhone X with Touch ID back, perhaps.
Face ID is now
the future.
The future for Apple, so who knows?
Ah, shucks.
Yeah, I mean, before we did this podcast, we had a list of things we wanted to say about the Internet of Things. Now, you had another thing for Synaptics. Which is kind of a bit esoteric to just a product.
So yeah, like browsing around in the Synaptics booth, of course, everybody expected the fingerprint sensor, but what was more of a surprise to me, which kind of fell through the cracks in the news, is that they actually now have like a commercial OLED DDIC. So DDIC meaning like display driver controller driving the actual OLED panel. So until now, Samsung has had like a major lead of several years in that area. So when people talk about OLED devices and OLED panels, there's two components. There's the panel itself, and there's also the DDIC, which you need to control the panel with.
So is this just a case of nobody else had a DDIC except Samsung, or is there a quality aspect?
There was another company, like another Korean company called Magnachip, which Samsung dual sourced back in the S3 days.
Okay.
But basically they dropped them for their own DDICs because they invested a lot more.
Yeah.
And basically Magnachip couldn't keep up in terms of features and technology. So yeah, until now, the two big vendors of OLEDs, so there was Samsung and there was LG.
Yeah.
So LG, the first OLED screen, I think it was like 3 years ago in 2015 in the LG Flex.
Yeah.
And then the next LG Flex 2. And nowadays, of course, we know we have the Pixel 2 XL.
Yeah.
With an OLED screen and the Rgb 30.
So they all use Samsung DDICs with...
They use something else. I don't know exactly what they use. Maybe an LG implementation or maybe some other third-party DDIC vendor. But here's the thing, like, there's been like a lot of controversy in regards to the Pixel screen and the V30 screen. So there's two reasons for that. First of all, it's the panel quality. So when you do the OLED emitter vapor deposition, you need to have like the latest Canon Toki machine, which there's only like 10 produced per year, and Samsung buys like 9 of them. So LG, of course, is production limited on the newest technology for actually producing the panels. So that's one reason. So you just have a panel which just uses all the technology in terms of production. The second reason is the DDIC. So the problem with the V30 and the Pixel 2 XL is at lower brightness, it gets very washed out and the colors just seem weird and there's black crush. And basically that's the reason for that is the DDIC. Because it cannot control the brightness based on PWM. It does it purely through voltage. And the big differentiating factor of Samsung OLED panels over the last few years is that they do control the OLED brightness through PWM, and they call it like smart dimming.
Yep.
And big surprise, of course, for me today was like Synaptics has now like a new OLED DDIC which has the same feature.
And it's just ready for...
And it's already ready. It's sampling right now. And already, they didn't say who, but there's already some smartphone vendors who are working on implementation. So what this means is over the next year or two, we're gonna see a lot more OLED devices with panels besides from Samsung, which are gonna be much higher quality.
And support more screen-related features through the DDIC, like dimming.
Yeah.
It's good to hear.
So basically this is like gonna be a big raise in terms of screen quality for third-party panels besides Samsung.
Yeah. So, moving on, I want to talk about a couple of things that I saw. First up, I want to talk about AData. Now, one of these, as a show this year, CES, there's been very few sort of breakthrough technology moments this year. Everything has kind of been sort of iterative. But one of the things that kind of caught me by surprise was AData. So AData, they make SSDs, they make storage, they make memory. And it turns out they now make M.3 drives.
M.3?
Exactly. What the hell is an M.3 drive?
What's that, Ian?
So AData was one of my last meetings this week, and I kind of had a glimpse that some other people had seen something, and I was wondering what was going on. So I went over and I saw, hey, that's an M.2 drive. No, wait, the connector is slightly different. Wait, that list of specs says M.3. What's M.3? Turns out it's the next generation form factor for PCIe SSDs, which also has hot swappable features. They were showing it in a new drive up to 2 terabytes, and they were also showing it in a dual processor 1U server with 36 of these M.3 removable bays. And this was meant to be a server built by AIC for 5G high-speed networks. And they said, hey, you have 36 drives here, put in, and each drive can have up to 8 terabytes if they were built that way. Now, obviously, with 36 drives, each taking 4 PCIe lanes, you can't do that with the 2 processors they had in the 1U, so they had PCIe switches to manage it all. I asked them to pop off the PCIe switches, the heat sinks, to find out what models they were, but they wouldn't let me. Otherwise, I'd end up breaking a $250,000 system. But yeah, M.3, hot swappable NGFF. Whether it's coming to consumers, who knows? At the minute, it seems like a very enterprisey play. It's, combating against ruler form factor. But actually, that's interesting, because that ruler form factor and the server that AData had on display was apparently designed for Samsung's 5G efforts. I have absolutely no idea. I took a lot of pictures. I'm basically going to shove it in front of Billy Tallis, our storage editor, and say, please tell me what this is. You're the one that does the research. Please tell me. But we'll see what that matters. AData actually had another slightly mini thing. They had a memory module that was encapsulated in Perspex, and they were using that non-conductive Novec M3 fluorinert liquid to help. So it was essentially a bare PCB with chips on and a Perspex thing around it, and like a spoonful of this fluorinert stuff to help cool it. And, just to add insult to injury, RGB LEDs.
Well, of course, RGB LEDs. What doesn't have RGB in it these days?
It's, they called it their Project Jellyfish, and they were just seeing how people would react to it. They actually had the Novec M3 non-conductive liquid spec sheets out. They didn't tell me exactly which one it was, but, it had conductivity, it had, mass per unit volume and boiling point, freezing point and everything like that. I have a picture. I need to go through it. But I remember 10 years ago when they used to use that stuff to, just sort of showcase mini PCs. We've seen it in the last couple of years showing off servers. Now, I was under the impression it was a cost of about $300 per gallon for this stuff, which for a server makes it expensive. For a memory module makes it, a bit cheaper. And then I was told, actually, no, the price is now $100 per litre.
That's not really an improvement.
No, it's not.
That's the same price.
So let's. It was literally a prototype, and it was like, hey, what do you think? We might see that more in Computex in 6 months. The last thing I want to talk about, and we'll probably end the podcast just after this, is a technology that's was showed last year, but this year is the second gen is actually really nice. It's from iBuyPower. It's called their Snowblind system. So iBuyPower is a system integrator in the US, and what they've done is they've worked with Intel to essentially put a transparent monitor inside the side panel of your PC. So you literally can have your desktop on the side of your PC, and instead of using, so it has sort of a backlight around the edge. Anytime, any of the pixels are white, it just makes display transparent. So you can see through into the components of the case. The idea here is that, you can put a logo on, when you're showing your PC off, you're not exactly going to be playing games on it. But, as they said, they can do this, display technology on almost any size panel. They had it on an ATX case, and it was 1280 by 1024 pixels. But with the second gen, it was brighter, it was sharper. And if you want to look at how the chassis industry has evolved over the last 10 years, aside from RGB, what major advancements has there been that have really been a major differentiating factor? Dual chamber, putting the power supply at the bottom, toolless, anything, nothing like that seems to come close to having a display in the side panel.
Technically, wouldn't the display count as a form of RGB?
Yeah.
But yes, you're right. I'm not even going to call it quite an interesting concept because I don't fully get it. Outside of, say, showing off at LAN parties, I don't see it would be that useful. But it is something different, and it's good that someone is trying something different.
So they don't sell the panel by itself. They just sell it as part of a complete pre-built system. They said that the panel costs about an extra $150 to $200 on the cost, which is fair enough because
you're basically putting a monitor into a side panel.
Yeah, and you connect it to one of your graphics cards. Yeah, but that was fairly interesting. And they said, "Hey, if you want to review one of our systems, let us know." And I'm thinking, what editor can I send it to? And then I forget we don't have a systems editor. But it would be nice to have that sort of content on AnandTech, I think. And this is me hinting at Ryan that we need to find a systems editor.
In due time.
This is CES. We do this every year. And it's Vegas. It's in the middle of the desert. And companies try and act like it's a party, but it really is hard work. Thank you guys for listening. Special shout out to all the editors we have back at home. Joe for helping lead our news, Anton for just plowing through the news, and all the others, Gavin, Patrick, Ganesh, and Brett, and Nate. It's
Billy. Actually, yeah, we pretty much have everyone working on CES. So.
Yeah, thanks to you guys for helping us get the news out and pointing us back to meeting rooms where we've forgotten to take pictures. And I hope you guys have enjoyed our CES coverage. Thanks, Ryan. Thanks, Andrei.
Yep. Thank you very much, Ian.
See you next time. See you at MWC.
Yep, that's our next show, MWC. Thanks, everyone, for